Notes. Alright, area of a polygon. When I'm talking polygon, it could be a hexagon, it could be a square, it could be a triangle, it could be pentagon. Did I say pentagon? Yeah, probably. It could be anything.
What about an octagon?
Could be an octagon. Could be decagon. We're going to start out with a pretty easy one. We're going to start with a hexagon.
I thought we were recording.
I am recording.
Oh, you're recording now?
Yes.
Then shut up.
Okay, so here we go, girls. Okay. Alright, so area of a polygon. What you do to find the area of this thing, just some definitions. You find the center of your polygon. Okay. Draw in from the center to one of the vertices what's called the radius. We'll call that R for radius. Okay, R stands for radius. Okay, then also, and I'm going to just draw in all of the radiuses. Okay, and notice it cuts. Yes, excellent. It cuts that hexagon into 6 triangles. And we already know how to find the area of triangles, right? 1 base times height divided by 2.
Yeah.
Okay. So base times height divided by 2. So all we need to know is the base, which we're given here. That's our base of the triangle. And then we've got this thing called the height, or the altitude. And I'm going to give you a new word, which I don't necessarily need to have you memorize this, but I'm going to call it A for altitude, or A for some reason in polygons, they have to come up with a new word for the height. And so if you see the word apothum, weird word, apothum, like a possum, I don't know. But apothum, all that stands for is the height of the triangle in the polygon. That's it. So don't let that word scare you.
Make the 3D box.
What's that?
Make the 3D box.
Oh, you're right. Yeah, try to see it just in 2 dimensions. Okay, yeah. But you could see that in 3 dimensions pretty easy. Alright, so A is the apothum, B is your base.
R is radius.
R is your radius. So those are the terms you need to know. Okay? So let's do an example of finding the area of this thing. And keep the whole finding the area of a triangle in mind when you do this. So let's do another hexagon. And let's actually calculate this one. Okay? So you find the center. Draw in this case I'm just going to draw in 1 radius, or 2 radiuses to make one of the triangles, so that we can calculate it. Okay, so you get out your calculator, because you're going to have to use some trig to do this.
Oh gosh.
You remember trig, and I think you're starting to get pretty good at it.
I don't remember.
A plus B, A squared plus B squared equals C squared.
You might use that. But the first thing we need is an angle. So we have 6 triangles if you went all the way around the circle. So what is each angle? How did you get that? So you take 360 degrees for a full circle divided by the 6 triangles we're cutting it into. So we know
Mine was negative 60.
that angle is 60 degrees.
Oh, mine.
Alright, so that's 60 degrees. But we're going to have to cut that in half. So I'm going to draw in another one. So we know how we found 60. So I don't have to draw over the top of the 60. I'm going to draw in another one of the triangles and work with this. So we're going to cut one of the triangles in half. So now what's my angle? 30 degrees. Okay. So we've got an angle of 30 degrees. We've got a right triangle here. And let's say that we're given the length of the side of 10 inches. I think I lied about the 7-minute thing. This is going to take me just a little longer, 7 minutes.
Oh my gosh.
Okay, so 10 inches is our base, right? What is the length from here to here? 5. So from right here to right here, we got 5, which is half the base of the triangle that we're dealing with. Yeah, so let's do sine, cosine, and tangent. We just need the apothem for the height of the triangle, and you'd have to use tangent. Right. So tangent of 30 degrees equals opposite over adjacent. So 5 over A. No. You would have to divide in this case. But you find tangent of 30. And I think 0.5774. Yeah.
8.659.
Over 1 equals 5 over A. So right. So 0.5, and I'll get out of your way, Trev. 774A equals 5. And so you take 5 divided by 0.5774.
8.89.
And I get, right, 8.66. We'll just go ahead. It is 9 if you round it. Depending on how far you need to round it. We're going to use 8.66 just to get a little more accuracy, not that we necessarily need to. It's also 5 times the square root of 3 if you remember, 5 times the square root of 3 if you remember the 30, 60, 90 triangle stuff. But if you don't remember that, just use trig. Okay, so we're ready to calculate the area of this. So what's the area of my triangle? Well, it's 10 for the whole base. I mean, you could use the 5. 10 for the base times 8.66, like Kayla's saying, divided by 2. That'll give you the area of one of the triangles. Times how many triangles am I making? 6 triangles. Times the number of triangles. So if you calculate that, you get approximately 259.8. If you know your 30, 60, 90 stuff, it would be 10 times 5 root 3 divided by 2 times 6.
I got 7.21.
Which would be, hold on here and I'll look at that, 25 root 3 times 6. And so that'd be 150 root 3, if you wanted the exact answer. So both 150 root 3 and 259.8 are the same, and I'm not sure how you got what you got. I'll have to look at yours and see. So that's how you find the area of any polygon, as long as it's a regular polygon. And let's see how many minutes I used up.